Imagine a surface combatant that balances the raw lethality of a $1,500,000,000 American Aegis destroyer, but carries a structural hull price tag of only $325 million. This is the paradox of Denmark and its bizarre mechanical marvel, the HDMS Niels Juel Frigate F-363. In the high-stakes chess game of the Baltic Sea, failing to field robust air defense leaves an entire naval task force exposed and defenseless against modern saturation strikes. Yet, this budget-friendly platform has completely shattered traditional Western naval doctrines by transforming from a hollow steel shell into a lethal air defense powerhouse in less than 30 minutes. In May 2022, at the Andøya test range in Norway, the HDMS Niels Juel achieved full operational capability by successfully firing the RIM-66 Standard Missile to Block 3A, marking the first time in history a Danish warship could intercept hostile aircraft and cruise missiles at ranges exceeding 150 kilometers. How did a nation that historically allocated less than 1.5% of its gross domestic product to defense manage to build a weapon system that leading global defense analysts argue outperforms multi-billion-dollar competitors? On paper, their only tactical salvation would be the radical StanFlex modular system, a Lego-style naval architecture that redefines modern surface warfare. But as tensions spike in 2026, is this modular setup a genuine technological breakthrough, or is it a vulnerable gamble when facing real combat operations? Before we go on, what do you think is the most critical feature of a modern frigate? Subscribe to the channel to never miss our deep dives into military technology, and tell me where you are watching from. To fully comprehend the mechanical lethality of this Danish platform, one must examine its unique physical blueprint. Displacing 6,645 tons with a length of 138.7 meters, this warship abandons traditional military naval architecture in favor of extreme economic pragmatism. The Danish defense industry reduced initial manufacturing expenses by constructing the hull using commercial merchant ship standards at the Odense Steel shipyard. Furthermore, intense automation allows the entire vessel to operate with a remarkably small crew of just 117 personnel, making it highly efficient compared to legacy surface combatants. The propulsion relies on 4 MTU 20V 80,000 M70 diesel engines, generating 32,800 kilowatts. While this setup leaves the vessel without expensive gas turbines and caps the maximum speed at 28 knots, it maximizes fuel efficiency for sustained long-range operations. However, the true technological core is the revolutionary StanFlex, or StanFlex, system. The hull is engineered with 6 standardized interchangeable slot positions. Using a single 15-ton crane, technicians can extract a module and install a completely different weapon system in less than 30 minutes. This allows the ship to swap an 8-cell Harpoon Block 2 anti-ship missile module for an Otobretta 76mm naval gun, or advanced anti-submarine warfare sonar equipment. The upper superstructure integrates a high-end hybrid sensor suite, combining the American Mk-41 vertical launching system with the Dutch Thales active phased array radar, known as APAR. This powerful radar network acts as the primary brain, enabling the ship to track multiple low radar cross-section targets simultaneously and guide the RIM-66 Standard Missile 2 to intercept incoming aerial threats. By utilizing this modular architecture, the Danish Navy successfully engineered a combat platform that fields heavy area air defense capabilities, while retaining the logistical flexibility of a multi-purpose utility ship. Yet, even the most ingenious mechanical designs are bound by the harsh realities of naval engineering and human limitations. The primary paradox of this modular blueprint is that while a crane can swap weapon systems in 30 minutes, a human crew cannot swap their operational training in 30 minutes. Leading global defense analysts argue that a specialized air defense team cannot instantly transform into expert anti-submarine warfare operators or mine countermeasures specialists. This human constraint leaves the vessel temporarily vulnerable during sudden tactical transitions, as retraining cycles require weeks of intense preparation, rendering the rapid modular concept less flexible during high-intensity, fast-paced warfare. Furthermore, integrating diverse hardware from multiple nations has exposed critical systemic vulnerabilities. In April 2024, during a routine naval exercise, the HDMS Niels Juel suffered a major technical malfunction involving the booster of a Harpoon Block II anti-ship missile. The missile booster activated during a mandatory test, but the onboard combat management system could not deactivate the launch sequence. Because the missile risked launching accidentally and exploding, the Danish military was forced to urgently seal off the strategic Great Belt Strait and close the surrounding airspace for several hours to prevent a catastrophe. This dangerous incident occurred shortly after its sister ship, the HDMS Ivar Huitfeldt, experienced a critical radar management failure while engaging hostile uncrewed aerial vehicles in the Red Sea. These successive events exposed a severe flaw in the integrated combat software, connecting the Dutch Thales active phased array radar with American Mk-41 vertical launching systems. By relying on commercial hull standards to keep construction costs at $325 million, the ship also lacks the heavy armor plating and robust damage control survivability features found on premium warships, leaving it highly exposed if a modern anti-ship cruise missile penetrates its digital defenses. Despite these technical integration hurdles, the HDMS Niels Juel remains the primary sentinel safeguarding the maritime chokepoints of Northern Europe. Moving into the current operations of 2026, the strategic landscape has shifted dramatically following the expansion of the North Atlantic Treaty Organization in the Baltic Sea. With the region effectively becoming an allied maritime zone, the Danish Navy has integrated this frigate into the intensive Baltic Sentry Task Force. This mission focuses heavily on protecting critical subsea infrastructure, after multiple commercial data cables and energy pipelines suffered hybrid warfare sabotage between 2024 and 2025. Operating as a mobile anti-access and area denial node, the warship utilizes its active phased array radar and RIM-66 Standard Missile 2 capability to project a dense air defense umbrella, neutralizing the potential deployment of hostile aircraft and anti-ship assets from the Kaliningrad exclave. Furthermore, the operational blueprint of this platform provides valuable strategic insights for mid-tier naval forces operating in contested zones like the Indo-Pacific. Rather than exhausting defense budgets on fixed $1 billion hulls, the Danish model demonstrates that standardizing cheap commercial hulls and investing heavily in advanced modular payloads is a viable path to regional deterrence. Over the next 12 months, defense planners project that the HDMS Niels Juel will lead the standing NATO Maritime Group 1, utilizing its modular slots to deploy advanced uncrewed underwater vehicles to scan deep shipping lanes for subsurface threats. Ultimately, this warship proves that modern naval supremacy is not achieved through massive expenditures, but through adaptable engineering. It raises a critical question for the future of global naval design. Can a modular combatant truly replace a purpose-built premium warship in a sustained high-intensity conflict? Or will software glitches always be the fatal flaw of this cost-effective approach? Share your thoughts in the comments section below.